In this lesson, we're going to go over some vocabulary that will prove to be very important when talking about transformations. Some of these words we may have already briefly mentioned in the introduction. Pre-image. A pre-image is a figure that's used as the input to a transformation. Okay, and you might remember that a transformation is like a function. We'll go into this in a moment. But you take a transformation and you input something into it, and it gives you something as an output. In this case, we're taking point A, we're transforming point A, and we're getting point A prime as an output. The prime notation is a very common notation that is used when discussing transformations. We often refer to a transformed point with the same label, but we put a prime or this little line on top of it to indicate that it is now referring to the transformed point. So the pre-image can also be defined as the original figure in a transformation of a figure. We're talking about geometric figures here. So the original figure, that's the input to the transformation, is the pre-image. The image is a figure that is the output of the transformation. Or we can say the image would be the new figure that results from a transformation of a figure, geometrical figure. And a transformation is a one-to-one function, which can also be called a mapping on the plane. Okay, it takes points as input, and then it gives points as output. A transformation further changes the position, shape, and or size of a geometric figure. We're going to come back to these three, but I want to go next to a rigid transformation or isometry because we're going to be using that definition in several others. So let's go down to V7. A rigid transformation, or isometry, is a transformation that preserves length, thus ensuring that the pre-image and image are congruent. Okay, and a non-rigid transformation is a transformation that does not preserve length. Okay, so these are sort of opposites of each other. Now with this information, let's go back and let's talk about the first of our transformations, which is reflection. Now, I want to point out that these three, all three of these, reflection, rotation, and translation, are all rigid transformations. They are all isometries. So we can make a notation here. These are all isometries. Okay, the figure that results from any of these, the image that results from any of these is going to be congruent with the pre-image. Okay, so a reflection. Reflection is a transformation that outputs a mirror image of a figure across a line of reflection. Ensuring that the pre-image and image are congruent. Okay, important. A rotation, and I think I'll do this in a slightly different color because it's getting a little crowded on this paper. I want to be sure you can identify the different definitions. A rotation is an isometry that turns a figure about a fixed point thus ensuring that the pre-image and image are congruent. And I guess translation I'm going to do on a separate piece of paper because it's just getting too crowded here. So a translation is an isometry that slides an object a fixed distance in a given direction, thus ensuring, once again, that the pre-image and image are congruent. Okay, so you should have these definitions in your notebook somewhere. It doesn't have to be all on this page. If it got too crowded, it'd be fine to put it somewhere else. And let's end up with the definition of orientation, which is V9. So orientation is the arrangement of points relative to one another after a transformation has occurred. And by arrangement of points, we usually talk about clockwise versus counterclockwise orientations. So let's take a look at what an example of this might be. Let's talk about a triangle. Let's call it ABC. And here I'm just making a rough sketch. Here we've got a triangle, ABC. Okay, and then let's talk about a triangle after an isometry has occurred. Now, isometry is going to maintain the shape and the size. I'm going to try to draw a triangle that's pretty much a congruent triangle. And I'm going to label this point A, and this point will be C, and this point will be B. So this is basically, let's say we had a right angle here, right angle here. These two triangles are congruent, but their orientations are different. So this left triangle, if we go from A, B to C, we find that we're going in a clockwise direction, right? From A to B to C and back to A gives us a clockwise movement. Whereas in this triangle, if we go from A to B to C and back to A, we're actually going in a counterclockwise direction. So in this case, we have a clockwise orientation to the left triangle, and we have a counterclockwise orientation to the right triangle. So the orientations are different, even though they are congruent and even though the transformation was an isometry. So let's take a look. Oh, I did want to introduce one other definition for you, which we're going to need in this next example. It's not on your notes, but I want you to add it to your notebook. And it is the definition of dilation. Okay, so dilation, before we get to these problems, dilation. And a dilation is a non-rigid transformation. That enlarges or reduces the original size of the figure. So a dilation enlarges or reduces the original size of the figure, but a dilation does not change the shape of the figure. So it may cause it to grow or to shrink, but the actual shape of the figure stays the same. Okay, in the next video we will continue.